Hello, this is Mr. Cunningham, and today we're going to be entering a new section in Chapter 7, which is Metallic Bonds and Bonding. So we use metals every day for various reasons, and probably in more ways than we realize. Uh, so every time that we flip a light switch, every time we use a frying pan, every time we take out a charger for our iPads, or we wear jewelry, we're taking advantage of the properties of metals. So there's three main properties that we're going to talk about of metals. And the first of these properties is that they're good conductors of heat and also electricity. So, for instance, when you flip that light switch, because metals are good conductors of electricity, they have copper wires that go from that light switch up into the light. So when you flip that light switch, electrons can run freely up into that light and allows the light to come on. It allows you to see. Also, every time you put a frying pan or pot on the stove and turn on whether it's gas, whether it's electric, turn on the heat, it allows the heat to be conducted through that metal and allows you to cook chicken or boil water or use it for whatever you want to use it for. The second property is that metals are ductile. And what being ductile means is that it can be formed into wire. So every time you take out your iPad charger, your phone charger, any type of cord has thin metallic wires that run through it. And that's what allows it to charge your phone, charge your iPad. Electrons run through that wire that's been put into a thin string, and it allows you to charge all your electronics. Also, metals are what we would call malleable, and malleable means they're allowed to be bent. So jewelers will bend rings, bend necklaces, so that they can hold different stones, so that they have intricate designs on them, but they can actually be formed even though they're still tough. They can still be formed and moved into position. So, but we can explain the properties of metals using something called the sea of electrons model.
So let's talk about this sea of electrons model. Sea of electrons model is explained as metal cations, which are positively charged, surrounded by a free-flowing sea of electrons, which are negatively charged. Now, the attraction between these positive and negative charges is actually what we call metallic bonds. But the sea of electrons model can help us understand why metals have the properties that they have. So we talked about metals being good conductors of heat and also electricity. Now, these free-flowing electrons is what gives them their ability, or metals their ability, to conduct electricity so well. Because the electrons aren't tied down and they're moving around freely, when you apply electric current like you do when you flip a light switch, electrons can flow very easily through the metal and can turn the light on. Now, heat, on the other hand, since these electrons are free-flowing and moving, when you heat a metal, so when you put that pot on the stove and turn on the heat, because these electrons are moving around freely, they're allowed to bang into each other more often. So in most other substances, electrons are usually tied to their own atom. But in metals, these electrons are kind of flying around. So in metals, these electrons make more collisions more often, which allows heat to be transferred much quicker. Now we can also explain the malleability and the ability of metals to be ductile by the sea of electrons model. So when we apply a force to a metal, what actually happens is it bends, right? It doesn't break, it bends usually. So we can explain this by what we just talked about with free-flowing electrons. because these electrons are allowed to move, all that they have to do is just move around the metal cation. So when the force is applied, the metal cations move, and then the electrons just surround the metal cations and are free-flowing just like usual. So the shape changes, but then it stays in that shape.
So, like we said earlier, we use metallic items just about every day. But very few of these items are actually made of one type of metal. So very rarely do we use something that's pure iron or pure gold or pure silver. That usually doesn't happen. What we usually do is use something called alloys. And alloys are a combination of two or more types of metals. So an example of an alloy would be something called sterling silver. And usually this is used for jewelry, but sterling silver is actually about 92% silver and 8% copper. And so that is a combination of metals that allows us to do, and it usually gives us better properties. So the importance of these alloys is that they are usually better, they have better properties than their two constituent metals. So, for instance, I like to use the comparison of peanut butter and jelly. So, really, peanut butter is good, and then you've got jelly that's good. But then when you put them together, there's this ultimate sandwich snack. So, some other alloys that we use are something I'm sure you've heard of is stainless steel. Stainless steel is actually a combination of four elements. And so it's mostly iron, it's 80% iron and about 18% chrome. And then there's small amounts of nickel and actually carbon thrown in to give that stainless steel its properties. It doesn't rust, it's very strong. So combining elements, metals, to make alloys can give us metallic objects that are even better than their constituent elements. So that's why alloys are so important to the way we live and how we do things. So this is going to wrap up our video lecture over metallic bonds and bonding. So just keep checking back on Schoology to see if we have any more videos, and I hope you have enjoyed your fall break.